The next important characterization of a matrix is determinant. Now this determinant of a matrix has a different definitions. First we will define a determinant of a 2 by 2 matrix. Then in terms of, that is using the definition of a 2 by 2 matrix determinant, we will define a 3 by 3 matrix determinant, and that using the definition of determinant of 3 by 3 matrix, which indirectly uses the definition of 2 by 2 matrix determinant, we will define the higher order. So this is an inclusive definition as the order increases. So first let us learn a 2 by 2 matrix definition, which is a very fundamental. When we have a matrix A which is in the form 2 by 2 matrix of elements A, B, C and D, then the determinant of A denoted by det A, and sometimes this is also denoted as mod A, but it should be read as det A. Now this value is again, as a matrix notation, it is denoted as the rows and columns remain same, but the matrix notation would be a square bracket. Then the determinant notation would be two vertical lines. Then the value which is denoted between two vertical lines says we need to evaluate the determinant. So this notation is a pure number. This is not an arrangement like a matrix. When we put them in a bracket, these positions have their importance, right? But when we denote them in a two perpendicular lines, then this is a single number. How will be the expansion of this? Yes, simply the cross product taken from A to D and B to C with a minus sign. So how will be this determinant? Cross product A into D and the cross product B into C taken with a minus sign in between. This is the determinant of the matrix A. Now let's consider a very simple matrix A taken as 1, 5, 4, 2. And we wanted to calculate det A of this matrix. That means what we are evaluating? We are evaluating determinant of the matrix having entries 1, 5, 4, 2. Then by definition it is cross product taken with a minus sign from left side. So how will be the elements in this? Yes, it would be 1 into 2 minus 5 into 4, that is 2 minus 20, which is minus 18. So what is determinant of this matrix A? The value of the determinant of the matrix is minus 18. Now using the determinant of a 2 by 2 matrix, we have a very important characterization of a higher order matrix, that is minor of an element. If you have a matrix A which is of order 3 by 3 and the element Aij represents the element in the ith row and the jth column, then the determinant obtained by removing the ith row and the jth column of matrix is called the minor of the element Aij. Now what do we mean by this? Say when you wanted to write the minor of A23. Now observe the element. What is this element A23? It's an element in the second row and the third column. That means we are talking about this particular element, right? Then the determinant obtained by removing the ith row and the jth column. So what it says? Remove the row and remove the column which contains that element. Then you are left with, from a 3 by 3 matrix, you are removing one row and one column. So what are you left with? You are left with a 2 by 2 matrix. Then the determinant of this 2 by 2 matrix. What is the 2 by 2 matrix that is formed by removing the second row and the third column? Yes, it is the elements left, that is A11, A12, A31 and A32. Then the determinant of this matrix, that means the cross product taken from left side with a minus sign, that means A11 into A32 minus A12 into A31. This value of the determinant is called the minor of the element A23. For your consideration here, M11 is given. Now what does M11 denotes? M11 denotes the minor of A11. In A11, how do we calculate the minor? Remove the first row and the first column. Then what is left? We are left with only a matrix of order 2 by 2 which is placed here. That is determinant of A22, A23, A32 and A33. Now this determinant, which is A22 into A33 minus of A32 into A23, is the minor of the element 11. Now can you tell me what will be the minor of A33? 31. When we wanted to write the minor of A31, this is an element present at the third row and the first column. That means we are supposed to remove the third row and the first column. Then what is the determinant that is remaining? After removing the third row and the first column, you are left with a 2 by 2 determinant, which is A12, A13, A22, A23, right? And how will be the determinant of this? It would be the cross product A12 into A23 minus A13 into A22. The value of this determinant is the minor of, that is M of 31, which is the minor of the element at the position 31, right? You can write the minors of all the 9 elements of this. Though here display shows 4 elements, can you write the minors of the next remaining 5 more elements? Try, it's a good practice. Now let's look at the next important characterization of an element, that is cofactor of an element. After calculating the minor Mij of an element, if you multiply the Mij with minus 1 to the power of I plus j, then the product so obtained is called the cofactor of the element Aij, and it is denoted by capital Aij. So when we wanted to write A11, that is what? It is the cofactor of, yes, the element which is present at the first row, first column. But by definition, what is cofactor? It is equal to minus 1 to the power of, what is row number and the column number? Yes, it is 1 plus 1 times the minor of 1, 1. Now how do we calculate the minor? Just now we have seen this would be minus 1 to the power of 2 times in the given matrix. Remove the row and the column which contains A11. That means this row, first row, and the first column are removed. Then what is the 2 by 2 matrix formed? Yes, it will be having A22, A23, A32 and A33. So what are these values? Minus 1 to the power of 2, that is plus 1 times A22 into A33 minus A32 into A23. This will be the cofactor of the element present at 1, 1. Now if we wanted to write the cofactor of element which is at A21, then by definition the cofactor of element present at 21, that is capital A21, will be how much? Yes, it is minus 1 to the power of the row number plus the column number, that is 2 plus 1 times the minor of the element at 21. Now how will be the minor of the element which is at 21? That means we have to remove the row, second row and the column, that is first column. When we remove the second row and the first column, the determinant would be minus 1 to the power of 3 times. What is the 2 by 2 matrix formed by removing the second row and the first column? Yes, A12, A13, A32, A33. Now minus 1 to the power of 3, that is minus 1 times. How will be the determinant? A12 into A33 minus A13 into A32. Now just for practice, tell me how will be the cofactor of element A33 here? Capital A33, which is the cofactor of the element A present at 33, would be minus 1 to the power of a row number plus column number, that is 33 times the minor of the element present at 33. Now what will be this number? This would be minus 1 to the power of 6 times. How do we find the minor? Remove the third row and the third column which contains the element A33. That means what is the 2 by 2 matrix left? It is A11, A12, A21, A22. So how will be the determinant of this 2 by 2 matrix? Minus 1 to the power of 6, that is plus 1 times A11, A22 minus A12, A21, right? Now can you practice writing the cofactors of the remaining 6 elements? Though here we practice it for 3. There are 6 more elements in the matrix. So you can practice writing the cofactors of the remaining 6. That plays a very important role, right? In the definition of the coming term, that is determinant of a matrix. Practice sufficient on finding the cofactors.